Hi, I'm Nicholas. In this session, I'll show you how you can extend Reality Composer Pro with plugins to make it possible for artists and content creators to work with assets directly in the editor, iterate quickly, and build lots of interesting 3D apps and games. This is a feature that will be available later this year. This is Reality Composer Pro 3, the latest version of Apple's game and 3D content editor for Reality Kit. This updated version comes with support for larger scenes, artist-friendly workflows for quick iterations over content, and the ability to preview scenes in headset. You can learn more about how to use Reality Composer Pro 3 in the session Iterate Your Spatial Scenes Faster with Reality Composer Pro 3. Another great session to check out is Design No-Code Games with Reality Composer Pro 3. That session shows how to build a game without writing any code by using Reality Composer Pro's visual scripting tool, ScriptGraph. In this presentation, I want to show what you can do with code. I'll show how you can build plugins in Xcode that expose your product-specific content to Reality Composer Pro 3. Your custom components will appear inside the editor, where they can be tweaked by artists and designers. For example, artists can change the water level or the rotation speed and see the cauldron react in real time without having to build and deploy an app. I'll first go through the general mechanism for extending the editor. Then, I'll show how to use that to get custom components and custom systems running in the editor. I'll also show how you can add your own custom animations to the sequencer timeline. And finally, I'll show how to create your own custom nodes for the ScriptGraph. I'll start by looking at the general mechanism for extending Reality Composer Pro and how that works when you're working on a team. I'll be working in the Chaparral Village game. This game was made by a team of developers, artists, and designers. The game has both a Reality Composer Pro project and an Xcode project. The editor project is typically used by the artists and designers to create the content of your experience, while the Xcode project is used by engineers to build the final app, as well as a plugin that lets artists create custom data in the editor. The Reality Composer Pro project and the Xcode project are linked together, so you can launch the app directly from within the editor. You can set up this linking for your own projects using the simulation bar at the top of the window. The editor project and the Xcode project live together in the same Git repository. Artists and engineers make changes locally and then commit and push to share them with the rest of the team. When you import a file into Reality Composer Pro 3, it gets converted to an internal data format and saved on disk as JSON files. You can use Git's built-in tools to merge your changes, but the editor also comes with a custom merge tool that can merge files with fewer conflicts than standard Git merge. To get data from Reality Composer Pro 3 into an app, you export it as a reality file, the serialization format for Reality Kit. Here's an illustration of how all of this fits together. The Xcode project is used to build the final game app, as well as the plugin framework for Reality Composer Pro 3. Reality Composer Pro 3 is used to set up the different 3D scenes and objects in the game. The RCP Custom Components framework makes the components and systems that developers have created available in the editor, so that the artists and level designers can edit them, see how they work, and improve the content interactively. Finally, the scenes created in Reality Composer Pro 3 are exported to a reality file, which is linked into and loaded by the app. When the code is updated, the developers build a new plugin framework for everybody on the team to use, as well as a new app. When the content is changed, a new reality file is exported to test in the final app. The Xcode project has been set up with two different schemas: Chaparral Village, which builds the actual app, and RCP Custom Components, which builds the plugin for Reality Composer Pro 3. All the custom components and custom systems in the project are shared between these two schemas. Let's see how that works. I'll use the plugin system to create a custom component and expose it to Reality Composer Pro. I want to work with the artist to create an effect for this cauldron. In the game, the cauldron will be used for mixing potions, and I want to be able to control the water level so it can go up and down as ingredients are added. I also want to add a swirling effect so you can see the water rotating when the potions are mixed. But let's start with just setting the water level. I could do this with a script graph. It would look something like this. On an update event, I get the water surface entity and move it to a specific position. But if I wanted to do something more advanced, it might make sense to use a custom component instead of a script graph. Script graphs and custom Swift code can do similar things, and often it's a personal preference what you want to use. But really big script graphs can be hard to maintain, so that might be a good reason to switch to Code. Code also lets you interact with other Apple APIs that are not available in ScriptGraph, such as SwiftUI. For the cauldron, I ultimately want the water level to tie into other systems, such as ingredients floating on the surface, so writing code makes sense. To do this, I start with creating a simple component to hold the water level of the cauldron. It has a single property that stores the water level. In addition to the component protocol, the cauldron also implements Codable. This is needed to be able to represent this component in Reality Composer Pro 3 and serialize it to reality files. For more advanced components that have runtime properties that shouldn't show up in the editor, it might also make sense to implement coding keys. But for this simple component, we just want to serialize all properties, so that's not needed. Next, I'll create a custom system for setting the water level. In the system update, I find the entities that have the cauldron component. Then, I look for the water mesh child entity and adjust the position of the water mesh based on the water level set in the cauldron component. After that, I need to make sure that Reality Composer Pro 3 can use my custom component and the corresponding system. To do this, I need to create a plugin class that implements the Reality Composer Pro plugin protocol. This protocol comes from the Reality Composer Pro Swift package. This package is automatically added to your Xcode project when you link it in the editor, using the Run with Xcode option in the simulation toolbar. In the setup method of this class, I use the context I get from Reality Composer Pro to register my components and systems. This makes these components and systems usable by the editor. I also need to make sure that Reality Composer Pro 3 can create the plugin. I do that by implementing a Create Reality Composer Pro plugin function that creates and returns my plugin. You'll notice that this function returns the class as a raw pointer. This is because I need this function to be exported in the DLL interface. I also need to mark it as a C function and give it an exported name so it can be found by the plugin loader. Let's see how all this works in practice. First, I'll create the cauldron component with the water level property. Then, I'll add the system that positions the water plane based on the property's value. Finally, let's register the component and the system with Reality Composer Pro. Now, I can build a plugin scheme to create the dynamic library. Now I can open the project in the editor. Since this project has plugins, Reality Composer Pro asks me if I trust it. I select Trust to load the plugins. Once I've accepted to load the plugin, the editor will show me the component that was imported. If I go to the project's build settings, the imported components and systems show up there too. I can also use this settings panel to specify a custom plugin directory. The imported components are found in the Custom Components folder in the project. Now that I've imported the component, and Reality Composer Pro 3 knows about it, I can add it to my cauldron entity. As I change the water level property in the editor, you can see the surface reacting. My custom system is running inside the editor through the plugin mechanism and changing the water level based on the property value. artists and designers can use this to fine-tune properties in the editor without having to rebuild and relaunch the app. If I want to debug my system, I can set a breakpoint in the code and attach to the editor application. When it runs my code, it will stop in the Xcode debugger and I can check my logic. Now that I have the basic water surface working, I want to take it to the next level by adding a swirling effect. As the player stirs the cauldron to mix the potion, I want the surface to bend into a vortex shape. To change the surface shape, a tech artist has built this vortex shader using the ShaderGraph system in Reality Composer Pro 3. The ShaderGraph has parameters for things like rotation speed, and it will create the vortex shape based on those parameters. I want to be able to control these parameters from my custom component. To do that, I start by adding some properties to guide the shape of the vortex. And then, I need to modify my cauldron system from before so that it propagates these parameters to the ShaderGraph. First, I retrieve the ShaderGraph material. Then, I use a helper function to compute the shape of the water surface based on the cauldron properties. I use the computed shape to set the ShaderGraph parameters. And finally, I assign this material back on the model. Let's see how this works in practice. First, I'll add my new properties to the cauldron. Then, I'll write a function to compute the water surface. Finally, I'll update the system so that it sets the shader parameters and then rebuild the plugin. Whenever I rebuild the plugin, I need to restart Reality Composer Pro to get the changes in. Reality Composer Pro will again ask me if I trust the project. If you don't want to see this dialog anymore, you can check the Don't Ask Again checkbox. Next, the dialog will appear that shows me the changes to my custom components. These changes all look good to me, so I'll accept them. If I go back to the cauldron component, I will see the new properties there. Let me set it up with some default values for the water level and vortex coefficient. Now, let me try some different values for the rotation speed. You can see that as I increase the rotation speed, the vortex gets steeper. Next, I want to talk about how to use plugins in the animation system. The animation sequencer supports custom animation actions that can be defined in the plugin and then added to the sequencer timeline. I want to create a custom action that sets the water level of the cauldron. To do this, I need to implement the entity action protocol, and to be saved in a reality file, it needs to be codable. My action takes two parameters, a start level and an end level for the water surface, so it can animate it between these two values. For the entity action protocol, I also need to return the animated value type as a transform. This is needed to access my entity in the animation executor. I also need to write the code that executes the action and updates the water level when the animation runs. To do this, I create a static subscribe function in my entity action that I will call from my plugin loading code. In this function, I use the subscribe method in entity action to subscribe to the updated event that gets called when RealityKit runs animations. I will use this to perform my custom animation action. I'll get the elapsed animation time as a normalized number between 0 and 1. Then I compute the current water level by using the normalized time to interpolate between the start and end water levels. I get the cauldron component from the entity and update its water level. And finally, I set the modified cauldron component back on the entity. The final piece of the puzzle is to register this custom animation with Reality Composer Pro 3. Just as with custom components and custom systems, I need to register the action with the context for the editor to be aware of it. I also need to call the subscribe function I created earlier so that the action executes on animation updates. Let's see how this works in practice. First, I will define my custom entity action. Then, I'll add the code that implements this action. Finally, I'll register this action with the editor and rebuild the plugin. When I restart the editor and open the project, it will show me that a new action was imported. Let's create an animation that uses this action. First, I'll create a new sequence in the editor. Then, I'll open the sequence and set the root entity of my animation to be a scene that contains the cauldron. I prepared a scene called Cauldron World for this purpose. Next, I'll add an animation track to the sequence and pick the cauldron as the entity I want to use for this track. Now I can drag the set water level action from the left panel into the timeline of my track to create an action that runs on the cauldron. I'll expand this action in the inspector so that I can set its parameters, the start and stop values for the cauldron's water level. I'll set the start value to 0.3 and the stop value to 0.5. Now, I can play back the animation and see the water level change based on my custom action. Artists and designers can use ScriptGraphs to create gameplay and interactivity in Reality Composer Pro 3 projects without having to write any code. The built-in script nodes go a long way, but if you want to take this to the next level, you can use a plugin to add custom nodes that the designers can make use of in their ScriptGraphs. The quickest way to expose a custom component to ScriptGraphs is to use the scriptable macro. For this, I first need to import the RealityKit scripting and RealityKit scripting macros modules. This is where this macro is defined. Just as the Reality Composer Pro Swift package, this package is automatically set up for you when you create your Xcode project from within Reality Composer Pro. Then, I simply tag my component struct with a scriptable macro. This will expand to a schema variable that describes the component so that I can register it with the scripting system. Like all other registrations, this happens in the setup function for the plugin. Scripting modules need to be registered on the main thread. I first create the scripting configuration for my project. In the initializer for the configuration, I need to return a list of all my scripting modules. I'll create a single module that holds my cauldron schema. This schema is generated by the scriptable macro. And then, I'll add my configuration to RealityKit scripting. Let's see how this works in practice. First, I'll import the scripting modules and add the scriptable macro to the cauldron component. Then, I'll add the code for registering the scripting module with the editor and rebuild the plugin. Let's create a script graph that makes use of the new custom nodes for the cauldron component. I'll start by adding a scripting component to my cauldron entity. I double-click the new component to open the ScriptGraph editor. Let's make it so that when the user presses a key on the keyboard, the water level changes. I'll start by adding an update node. This node fires every time the scene updates. Next, I'll add an if node and hook it up to a key press so that the node fires whenever the key is pressed. I'll hook up the true connector from the if node to set the water level of the cauldron. Now, when the A key is pressed, the water level of the cauldron will be set to 0.25. I'll hook up another key to set a different water level. To do that, let me just copy and paste the whole graph. Then, in the copy, I'll change the key to Z and the water level to 0.5. I can test this out by opening a simulation view. As I press the A and C keys, the water level goes up and down. That was a lot of ground I covered in this session. I showed you how to create some simple plugins using Xcode and extend the functionality of the editor to work with your app's data and even run your code inside the editor. To learn more, I suggest checking out the Explore Advances in RealityKit session to find out about the latest additions to RealityKit. I also recommend going through the Supercharge Your Spatial Workflows with Reality Composer Pro 3 session that covers how to improve your productivity with the editor. I look forward to see what amazing experiences you will create with the new Reality Composer Pro 3. Thanks for watching.